To explain, on this video, we've used text files 102 and we've changed the name of it to arrays 101. And also on the text file, I added an extra variable or an extra field in there for the pupil's height. Now you'll notice pupil's height is 1.6, so it contains decimal places. So we need to, for our pupil class, firstly, we need to actually, on our pupils class, we need to actually add a variable to hold the height. Now, the data type we use to store decimal places, it could be a double, or it could be a float. Some of them, other programming languages have something called a real, and I think even there's other ones which even contain something called decimal. There's also a single, but yeah, don't worry about that. I don't even know if Java has a single. Anyway, different programming languages deal with different data types for that. For now, we're just going to use a float. It's a nice, easy one to work with for decimal places or handling decimal places. And we are going to call it height. Now, we obviously then need to make our fully parameterized constructor also receive a float height, and you'll see it will cause red underlines in our pupil manager as soon as it's realized that it has changed. And yep, there we go, red underlines in the pupil manager because obviously it's now different. So we'll do this dot height is equal to height. So we've updated this class to also include a height now. Also must create the getters and setters for it so we can work with it in more detail. Alt insert getters and setters for height. Done. Now that we've done that, we're going to go back to our pupil manager, and we're now going to have to add in here as well the float. So I'm just updating it to be able to contain it. I actually can just pause the video for this because this should be part and parcel of knowledge. The only difference here is that it's a float, not an int, which is a different data type. It's really not that challenging. In this part, exactly like we've done serec.nextInt or next, depending on what data type, you'll see there that there's something that says next float, which will receive the next decimal places there, and then we'll send that through. Okay, so here we'll just send through height, just to make sure that it is. I'm going to add into my toString as well the height of the person. So we've got their house metric here. We also now want to add height. And then after we do this, we can actually just check that it is definitely working. So you want to enter and a height at the bottom.
Yes, please.
But then we've got enters between the subjects, so it's going to be like a long. I'll put a tab. Tabs are prettier. Okay, maybe not, but just because I can. Yeah, did I just press play and close it? That was very entertaining. Alright, so you'll check now. Okay, so KP, matric starting year 2016, height 1.6, and so forth, with the subjects underneath it. Okay. Let's close that. Just for interest's sake, okay, now I won't go into GUI manipulation now, never mind. Let's get focused. Now, what if I wanted to, this array, sort by height? Oh, sorry. First, let's just say I want to create a method that will search for Amir. So I want to search for a name. So here I'm going to go public. I want to create a method. Now, here's the big differences. One, I can create one that will return it. So I can say search for search name that will receive. Oh, actually, I'm just going to create a search method, and I'm going to receive a string name. Now, I can return an int, which will mean it will return the position in which Amir exists, and will not actually return an instance. Or, I could actually just go and say return pupil, which means it will return the actual physical instance of the pupil. Now, remember I went through the fact that this actually just returns a memory location, and not the actual, doesn't create a copy of it. It literally returns a memory reference to it. Now, let me just zoom into this. Now, I've got a pupil search string name. So the first thing we're going to do is we're going to loop through our array like we would always do. Do you guys get that? Now, all we're going to do then is say, while I is less than num pupils, and then all I'm going to do is I'm going to say if pupils position I dot, so you have to receive the attribute which is applicable. Which attribute is applicable here? No, because this is search for the name, right? So get name dot equals to, and then we would want it to search dot equals to name. So basically, now I'm in the way. I'm going to become top left. So basically it's going to say equals name, and then now if it is equal to name, what are we going to return? We can just directly return pupils position I. Done. But now there's a red underline. Now this red underline says that it could potentially happen that nothing is returned. So in other words, if I search for Bob, is there a Bob in this class? No. So I need to return something if it doesn't exist, so I can return null. Now remember, previously I've done the exact same thing with you guys, but I've told you to create a temporary pupil and work with that. You can also do that, create a temporary pupil and return pupil here, and then you'll just add that there. But in this case, you would want to exit the loop as soon as this would work as well. So return pupils I directly. Yes?
If you don't create a temporary variable, will pupils position I override null?
Well, are you saying if we do create? No, well, in this case,
We don't create a variable.
okay, as soon as you return, this method ends.
Yeah.
So in other words, it will not continue looping, so it will not go down to this segment.
Okay.
So in other words, as soon as I return, it exits this whole entire search function and it's gone. Now, if you created a temporary variable, so if I said pupil, that's not how you spell pupil, temp is equal to null, and then at the end I returned temp, then I would have to here, instead of doing that, I would have to go, okay, temp is equal to pupils, but then right now it's bad algorithms, because once you found it, you found it. So you don't need to find it again. So you actually need to then do a break, which means as soon as you found it, you'll exit the loop and then it will return it. Does that make sense?
Yeah.
Both ways is completely correct, and I don't mind which way you do it. But if you do use a temporary variable, you have to use a break so that you exit the loop when you find it. So you don't, in this case of finding, unless you wanted to do something where you wanted to, then it would be an array, and then you'd have to search for every single individual item and add it to an array or a temporary array and then return that temporary array. Now, I've lost my train of thought. Okay, so now we've done a search for name. Now, here's something that's not really expected. What if I did this? What is this term called? I've got now a method of the exact same name. What is this called? I've got a search method here and I've got a search method here. But now it says two methods of the exact same name. The only difference is the parameters. The return type is the exact same. The parameters are different. And this is what's called overloaded. Meaning that do you guys remember when we used Amira, I like the photo. Anyway, do you guys remember when we did geometry, not show message dialog or show input dialogs, when we use those? So why am I saying, do you remember? Check how many of them are. This is called overloaded. They're the exact same method, the only difference is what I sent through to it. The method is considered overloaded if you wanted to do slightly different stuff depending on what is sent through to it. So here we're searching by name, here we're searching by height. So now we're just going to go for our tab. Actually, in this case, what I would do in a scenario like this, I would just copy the whole entire other method, paste it into here. I'll change it from get name to dot get height, and I'll say equals to height. Now, is height the correct data type? Did I make it the correct data type? What data type should this be? Okay, so you'll be comparing those two, and if they are the same, then you return that. So now I've created a looping. So this is showing you how to search plus overload a method. Do you guys get that? So this is for a search and overload. Now, the next thing we're going to deal with, we're going to go find max, or let's say get tallest, which is a search for max. So we're going to create a method here, public pupil get tallest, and this method doesn't require any parameters, and we want to find the highest. So firstly, like we determined when we were in the front of the class, we need to actually store the maximum. We're going to start the maximum at Well, okay, I'm going to leave that for now. And we're going to store the position. So what I suggest that we do, I just said do. Anyway, I'm going to store the max to be I'm going to say if num pupil is greater than 0, so in other words, there is someone in the array, then max is going to equal to pupils position 0. So like Mitchell had said during his dot get no, actually I don't need to do that, pupils position 0 dot get height. It was like what Mitchell suggested. Fail. Yeah. Now, it's like what Mitchell had said. He said, how do we begin it? You begin it by making the first person, whoever's in the array, the first in the array, you just set as being the tallest. Happy birthday for you, you're the tallest. So, happy birthday, you're the tallest. If the pupil array is 0, then obviously the tallest person is null, because there is no persons. Do you guys get that? Now what we need to do is we're going to loop through the rest to determine who the tallest is. So we're going to go for tab. Now at the end, we're just going to return pupils at position pos. Does that make sense? So now I'm going to start, because we've already worked with the first person, we've set the first person as being our tallest. Do you guys follow that? So where do I want to start now? Do I need to compare Mitchell against Mitchell?
No.
I want to then compare Liam against Mitchell. I think Liam, you were the second in line, right? Okay. So now in this case, I'm then going to say if, okay, sorry, my loop, I haven't looped till the end of the array, so loop until none pupil. So then I'm just going to say if pupils position I dot get height is greater than max, then in this case, who is now the tallest? I is now taller than the max, so I'll just say position I, the max is now position I, and the pos of the max is now position I. Do you guys get that?
Yeah.
So literally I'm looping through it, I'm storing a max, and I'm saying this is the current max. And if I wanted to get the tallest, okay, so do you guys follow this? I start off by just setting the first person as being the max and the position of 0 being the max. If there is no people, I return null. I then loop through the array. If the pupil.get height is greater than max, then return the height. Sorry, then not return anything. Sorry, then store that as being the new tallest person. Like we did when we were standing up there. We looked at one person, we have to compare them. Is that person taller than that person? If yes, then we say that person is now the new tallest. So now that person is the tallest person. They need to be on the thing. So then you compare the next person. And is that person taller than that person? No. So then you go to the next person. And so forth. And then whoever's the last left as being the tallest person is the tallest person, and that's returned. Now, how would I convert this to become get the shortest person? So all you'll do is to get shortest,
Change your name. Sure.
I would, for logic's sake, I would call this min now. And you would say that is the min. And then all you would do is change this, is you would say if the person's height is less than min, done. So all you do is you'll change the ways in which you're working with. Instead of greater than, you work with less than. Alrighty then. After searching was the sorting. Now sorting is a little bit trickier, but I'm going to show. It's so easy if you do it this way. Public void sort by height. ASC for ascending. So that's shortest to tallest, right?
Yeah.
Okay. Rule of easy way to do a sort. For tab. Inside the for statement, go for tab. So now we have a loop inside a loop. So we have I and we have j. I should start at 0 and end at the length of the array minus 1. Do you guys remember? You don't need to compare the last person. The last person, after you sort through every single other one, when you get to the last person, so you'll find shortest, second shortest, third shortest. When you get to absolute tallest, so in other words, the least shortest person, that is the least shortest person. You don't need to compare it because all of the rest have been sorted. So therefore, the last person will already be the last person. You don't need to get to that. That's why we do that. And J, we don't need to compare the first person with the first person. So what do we do? I plus 1. We don't set it to 1 because then we'll always be comparing 1. It's whatever I is. When we're looking for the shortest person, it is I plus 1. When we're looking for the second tallest person, it is I plus 1. So you always want to move it down the array. So it starts at the lower position of the array. So what you're going to do there is you're going to go, and now you have to compare whether the person is shorter than the other person. So you're going to say, if pupils position J, so who I'm looking at, is Liam, I'm gonna for terms' sake, I'm gonna say this descending, because I'm just literally saying, if I'm starting from the right hand side in the order we work, I start off by saying position 0 was Mitchell. The next person was Liam. And I said, I'm basically saying, is position J dot get height, so that's the property I'm working with, is that height greater than pupils position I dot get height? So if Liam is taller than Mitchell, then we want to swap them. And to swap them, we create a temporary, and we make that equal to pupils, whichever one. And then we say pupils, whichever one we just worked with, is equal to pupils, the other one. And then we can say pupils, the other one is equal to temp. So literally, we've just swapped them around. Do you guys get that? Yes, no?
So wouldn't it increment I twice? Because in the first
Oh, thank you. No, it won't, because it doesn't store it in I. It stores whatever I plus 1 into J. Does that make sense? Was that where you were getting confused? Okay, so I plus 1, it doesn't store it in I, so I doesn't change there. It stores whatever I plus 1 is into J. Now, over here, we're just comparing them, and if we do need to swap them, we swap them. So in the case of our example, Mitchell and Liam didn't need to swap. But then Mitchell and when we got to Sky, which is Sky taller than? Yes, we would have swapped them. And then now Sky would have been the new tallest, and we would have carried on looping to just check until we got to the smallest person. Or until we got all the way to the end, and that we now knew that was the tallest person. We would then go, I would increment to 1, and now we would be finding the second tallest person. We'll loop through the rest of the array and find the second tallest person, and so forth. And then after this is done, it's done. This has been sorted by height ascending. Now I'm going to, I know I could just copy and paste this whole method, and it would work. I'll just have to change one thing. But I'm going to be doing this again just to show you a quick way of actually doing it. For tab, I is 0 less than num pupils minus 1. J is less than num pupils, which I forgot to change in the last one. Then J is equal to I plus, that's not I, that's I plus 1. And then I just go if, open brackets, pupils position J dot get height dot get class dot get height is less than pupils position I dot get height. Then I would simply go swap, so I'd go pupils temp is equal to pupils position J semicolon pupils position J. I could have just copied and pasted completely, but I'm just wanting to show you in a lot of ways a sort kind of becomes a bit of a regurgitation thing, that you can just literally follow the same oops, my bad. You can follow the same logical structure, and it goes quite quickly. Okay, so that's to sort ascending. That's to sort descending. Alrighty, that's the end of the array that I wanted to go through today. Goodbye.